Welcome to Calculus. I'm Jonathan Bartlett, author of Calculus from the Ground Up, and this is the first video in our Calculus course series. We'll be covering the book Calculus from the Ground Up. So in this video, I just wanted to introduce you to the subject a little bit to get you a feel for what it is and what we'll be doing in calculus. A lot of people get scared by calculus, but calculus is actually a very straightforward subject. There's two main operations in calculus that we'll be learning throughout the year. But these two operations give you a whole range of possibilities on doing math in new ways. I really enjoy calculus because I find that it's a lot more creative than regular math and algebra. It teaches you to create new things that help you to solve problems. And so you create the math. You don't just use the math. You know, in a lot of the other subjects, they give you all these equations, and you have to memorize the equations and how the equations apply to whatever you're doing. Well, in calculus, what you learn is you learn how to make those yourself. You don't have to rely on memorizing lists and lists of equations, although there are things to memorize. You learn the technique of building them yourself. So all these equations that you've learned, equation about the volume of a sphere, the volume of a cone, all these different things that you've learned. In calculus, we actually learn where those come from. And so I really enjoy calculus because I feel like it's kind of the undergirding of a lot of the math that, you know, in a lot of the other subjects, it's kind of like the math comes from heaven and somebody just hands you this formula and you're like, why does that work? Well, calculus tells you why these things work. And so you kind of get at the underbelly of what math is and where it came from. So a lot of the equations that you get in physics, if you've ever done those things where you drop balls and have to calculate when they're going to hit the ground, all those, physics, a lot of times they say, well, it's from experiment, but those equations didn't come from experiment, they came from calculus. So in calculus, we learn how to actually put all these ideas together into equations to tell us new things about processes and shapes and things that we were already familiar with. So calculus relies on two main operations. And they've got big names, but they're actually pretty straightforward into what they do. The first one is the derivative. And one thing, if you want to go ahead and start studying already, anytime you see the word derivative, you should immediately think slope. Okay? Your derivative is your slope. And so what's a slope? Well, just imagine that we had some sort of a graph here. Okay, we've got a nice little graph. So at any point, so let's imagine that this is a hill, and we're going to go sledding on the hill. So at any point, this has an elevation, right? So any given point here, you can find the distance and the elevation, okay? And that's interesting information. But what would be really helpful is to know if we're going to be sledding, we need to know when we're going to need to push our sled up the hill, where we can sit and rest while we wait to actually go sledding, and where the sled is going to be going down the hill on its own. So if we're going in this direction, okay, well when we're at the bottom of the hill, it's basically flat. So the sled's not going to go anywhere, and we don't have to do anything to keep it from going anywhere. But if we're going up the hill, when the slope is going up, then we have to push the sled up the hill. Okay, it's not doing anything on its own. It's actually working against us as we push it up. But then it starts to flatten out as we get towards the top. And when it comes to the very top, it's actually flat at the top of the hill. So we can just leave our sled there, and it's not going to go anywhere. So at the top, the very top of this slope, it's actually flat. Okay. So then, when we're ready to ride our sled, we just hop on, and now the slope is going down, and so it will pull our sled to the bottom of the hill. And then presumably when it gets to the bottom, we'll be at a flat space again. So if you imagine that there's an equation governing the hill, we'll just say that just some equation, we don't know what it is, so it's some function of x. Okay, so the equation tells us how high the hill is at each point. Okay, well, what the derivative will tell us is what the slope is at each point. So it will tell us if we're going to be pushing our sled up the hill, if we can just sit and rest, or if we're going to be sliding down the hill. Okay, so that's what the derivative tells us. You might say, well, why is that important? Okay, well, to understand that, let's imagine that instead of this representing a hill, that this represents a graph that we've determined that, let's say, something that we're trying to sell. Okay, and we've developed an equation that will tell us, if we set the price here, then that means we'll sell this many units and we'll get this much profit. Well, as you decrease the price, you might sell more units, but you'll be less profitable because there's not enough profit in each unit. So as you increase the price, you'll get more profit per unit, but the number of people willing to pay that price will drop off. And so at some point you'll hit a maximum. So if we imagine that this side of the graph, this side of the graph is the price that you're selling whatever it is for, and this side of the graph is the profit. Well, what we want to know is where this maximum value is going to occur. So if we have an equation that gives us this type of a graph, we can use the slope to find out where the actual very tippy top point of this graph is. We find out where is the slope flat. Okay? And that will tell us where this thing has its top. And so that's kind of what you use the derivative for. One of the main uses. The second big operation of calculus is the integral. And the integral, anytime you see the word integral, one of its main applications is in finding areas. It's one of the main things that you use integrals for. And so again, if we have, you're used to finding, hopefully you're used to finding areas. If I gave you a square, you could find the area. If I gave you a triangle, right, what's triangle? 1/2 base times height. Right? If I gave you a circle, right? But what if I gave you a really funny shape? What if I gave you a shape that looks like this? What's the area of that? Okay, so with integrals, if we have an equation that tells us what the edges of the shape are, we can then find the area. And areas are used for all sorts of things because they actually represent summations, totalings of things. And so in physics, you often say, well, if I know this law about something that happens in an instant. But what's the effect of that law occurring over a long period of time? Well, the integral will tell you how to relate what happens in that instant to what happens over the period of time. And so those are the two operations. They're describing them is pretty straightforward, but we'll spend basically most of a semester on each one, and we'll look at all different applications. We'll learn how to apply these to different equations. We'll learn how to use these in a variety of different situations. And I think you'll find that the creativity and the depth that you get from calculus, you'll learn where all of your other math came from. You no longer have to sit around and wonder who came up with this. You'll have come up with this because you'll have learned the underlying principles behind all the formulas that were given to you. So I hope you press on in calculus. The next few videos will cover some of the things that hopefully you already know, but just kind of a review of some of the important parts of other areas of math. My calculus course, we don't focus too much on trigonometry, so it's okay if you came to us from algebra, as long as you have a pretty good grasp on algebra and the basics of geometry, you should do fine. So anyway, I hope you enjoyed the course, and I hope you stick with it. Thank you very much.